Limits are very useful when we start talking about asymptotes, and these are limits that involve infinity. A vertical asymptote, remember that's this way, vertical line up and down, of x equals a is if we have a function where we have this vertical asymptote, what that means is you either have one or both heading towards infinity, whether you come from the left or the right. So we could have a situation like this where we're coming from the right, we're heading towards positive infinity, we're coming from the left, we have negative infinity, or they could both go up to positive infinity, or we could have a situation where it's only on one piece here, and it's heading towards, but if on one side or the other you've got your function heading towards infinity or negative infinity, then you have a vertical asymptote. Now, horizontal asymptotes are a little bit different, and we've talked about one little special thing about horizontal asymptotes when we talked about rational functions. And you have to remember that horizontal asymptotes can be crossed, because what is a horizontal asymptote? Well, by definition, a horizontal asymptote is what happens when we get out towards infinity. So for vertical asymptotes, our limits are equal to plus or minus infinity, but for horizontal asymptotes, we're looking at our limit as we go to infinity or to negative infinity. So if we have a horizontal asymptote, then we'll have, let's say it's here at y equals 2. Then you have a function that as we head out towards infinity, it gets closer and closer to that. Or as we head out towards negative infinity. And you could have a situation, as I said, where you cross it. Sometimes it crosses it multiple times and then gets closer and closer to it. So our horizontal asymptote is what happens way out as x goes to positive or negative infinity. And a vertical asymptote, the limit equals positive or negative infinity. So let's look at a couple of examples of that. Let's say we want the limit as x goes to 5 from the right of this function, x squared plus 2x minus 3 over x squared minus 3x minus 10. Well, with rational functions, when you're doing limits, it will always help you to go ahead and just factor it as much as you can to see if you have any holes or to see if you're going to have any asymptotes. So we look at this and we see that we have an asymptote because the bottom here, if we plug in this 5, it's going to be 0. So we're going to have an asymptote at 5. So we can look at our graph. We have an asymptote at -2. We have an asymptote at 5. We actually have a horizontal asymptote at y equals 1, which we'll look at in a minute. And our function looks like this. So we see that as we go from the right towards 5, we're going towards positive infinity. So when we know we have an asymptote, we need to look at our graph or think about it and figure out if we're going to go to positive or negative infinity. Remember, that means the limit doesn't exist, but we go ahead and denote it with the infinity sign so that we can see how it doesn't exist. Now for this, y equals 1 is our horizontal asymptote, which means that the limit as x goes to infinity of this function equals 1. Now, there's a couple of different ways we can do this. You can remember your horizontal asymptote rules. Remember those: if the degree of the top is less than the degree of the bottom, then you have a horizontal asymptote at y equals 0. If the degree of the top is greater than the degree of the bottom, then we have an oblique asymptote, not a horizontal asymptote. And if the degrees are equal to each other, we take the ratio of the leading coefficients. Hopefully you remember that from rational functions. Now the other thing you can do is you can use that method we used with sequences when we were finding the limit of the sequence, where we multiplied by 1 in disguise to get rid of the x's on the top. So we end up with the limit as x goes to infinity of 1 plus 2 over x minus 3 over x squared all over 1 minus 3 over x minus 10 over x squared. And if we split all these limits up, we'll have the limit as x goes to infinity of 1, which is 1, and the limit as x goes to infinity of 2 over x, which is 0, minus the limit as x goes to infinity of 3 over x squared, which is 0, over the limit as x goes to infinity of 1, which is just 1, it's a constant. The limit as x goes to infinity of this is 0, and of this is 0 as well, and so we can get 1 from that. So you can use that technique that we learned from the sequences to help you with this, because those all work for the functions as well. But this is also something that will make your life easier if you will remember this from rational functions. So vertical asymptotes, you're looking at the limit as x goes towards a number from the right or the left, and it has to equal plus or minus infinity. Horizontal asymptotes, you're looking at the limit as x goes to plus or minus infinity to get a number, which gives you the horizontal asymptote.